All right, let's dive in. When we look at AI right now, it's easy to think it's all about getting bigger, faster, and smarter. But something else is happening, something much more fundamental. We're witnessing a great divergence, a split in how intelligence itself is evolving.
For years, the whole story has been that AI is on this unstoppable rocket ship, getting smarter and smarter every single day. But what if that's not really the whole picture? What if, instead of just climbing the same ladder of intelligence that we're on, AI is building a completely different ladder altogether?
And this really gets to the heart of it. Our brains, biological intelligence, evolve for what you could call semantic fidelity. We thrive in the messy, rich context of the real world. We hold on to all the tiny, meaningful details. AI, on the other hand, is built for one thing: pure information efficiency. It does this through a process called statistical compression, and these are two totally different ways of seeing the world.
Okay, so let's really break that down. We're going to dig into why these two paths are splitting apart and what it actually means when we talk about how we think versus how an AI thinks. They're not just different in degree, they're different in kind.
Just think about how your own mind works for a second. You see a robin, you see a blue jay, and boom, your brain instantly tags them both as birds. But, and this is the crucial part, you don't just throw away the details. You still know one has a red breast and the other has that bright blue crest. You keep all that nuance because our knowledge is grounded in actual, physical, real-world experience. That's semantic fidelity right there.
Now, AI's approach, it's from another planet. It uses something called aggressive statistical compression. So instead of understanding what a bird is, it just turns the word bird into coordinates on a massive map of numbers. Meaning is just about what's statistically likely to be nearby. It's unbelievably efficient for, say, predicting the next word in a sentence, but it has zero of that rich, felt understanding that we have.
And wow, when you put them side by side, the differences are just staggering. Look at power consumption. Your brain is humming along on about 20 watts of power. That's less than a dim light bulb. A cutting-edge AI supercomputer, it can pull up to 50 megawatts. It's a completely different universe of energy for a completely different kind of intelligence, one that's purely probabilistic, not grounded in the real world at all. And this absolutely insane thirst for power isn't just a quirky fact. It's creating a huge real-world problem. We're hitting a hardware bottleneck that is forcing us to completely rethink the very machines that run AI. Seriously, just let that number sink in for a minute. 50 megawatts. That is enough electricity to power a small city, all for just one AI computer. When you put that next to the beautiful, elegant efficiency of our 20-watt brain, you realize our current approach is just physically unsustainable. We can't just keep building bigger and bigger data centers forever.
So the root of the problem is actually something that's been around since the dawn of computing. It's called the von Neumann bottleneck. See, in basically every computer we use, the processor and the memory are physically separate. The machine wastes a ton of time and energy just shuttling data back and forth. For AI, that little traffic jam has become a full-blown crisis.
And so, the race is on to build a totally new kind of computer. On one side, you've got the traditional way of doing things, with GPUs and CPUs. But on the other, there's this incredible new idea: neuromorphic computing. We're talking about brain-inspired chips that process information in parallel, just like our own neurons, promising a future of absolutely radical energy efficiency. And this is not science fiction, folks. This is happening right now. Researchers recently showed off the spec chip. Get this. It consumes just 0.42 milliwatts when it's idle. That's an incredible breakthrough. It proves that this brain-inspired path isn't just a theory, it's actively being built as we speak.
Okay, so let's shift gears from hardware to software. Because even with all this computing power, AI smacks into another massive wall when it tries to leave the clean digital world and operate in our messy physical one. People are calling it the reality gap.
And this gap shows up even in AI's own backyard, writing code. I mean, this quote from senior developers says it all. AI is fantastic at churning out lines of code, 30 to 50% of it in major companies. But it really struggles to get the big picture, the business goals, the system architecture. It just doesn't have the context. And you can see the performance just fall off a cliff. For simple, isolated bug fixes, AI is a rock star. It succeeds over 80% of the time. That is genuinely impressive. But ask it to manage the evolution of a complex system or to navigate a huge enterprise codebase, the success rate plummets to below 25%. That long-term contextual reasoning just isn't there yet.
And this reality gap gets even wider when you step into the physical world, like agriculture. Sure, an AI can absolutely master a farming simulation, a little harvest game, but put it in a real field with unpredictable weather, pests, and soil, it falls apart. It's great at analyzing satellite images from high above, but it can't yet make the autonomous, grounded decisions a farmer makes every day.
So all of these huge technical shifts are, of course, having a massive impact on the business of AI. The market is growing up, and it's happening fast. We're moving from this chaotic, primordial soup phase into a much more consolidated five-way race for dominance.
And the finalists are the heavy hitters you'd probably guess, but each one is playing a different game. You've got Google going for full vertical integration, from the chips all the way up to the models. Meta is weaponizing open source to try and win on distribution, and others are focused on speed, enterprise deals. Everyone's carving out their own unique superpower.
But here's the really crucial part. The investors, the smart money, they're not just throwing cash at general-purpose models anymore. Firms like Sequoia and Y Combinator are now pouring money into specialized, vertical AI. They're funding AI for lawyers, AI for synthetic biology, these very specific domains where deep knowledge is everything.
And this whole thing has led to a pretty major cultural shift, which is perfectly captured by this term, vibe coding. It's this idea that programming is becoming less about writing super strict lines of code and more about just describing what you want in plain English and letting a team of AI agents figure out the how. It's a really profound change in how we build things. So, where does all this go from here? Well, the entire focus of the industry is shifting, and shifting dramatically. The era of just chasing raw computational power, of just making bigger models, seems to be giving way to a brand new priority: real-world utility.
And that points to 4 key priorities for the near future. First, we have agent orchestration, basically getting all these specialized AIs to work together as a team. Second, scaling up those super-efficient neuromorphic chips. Third is semantic realignment, a massive effort to bridge AI's statistical world with our human contextual one. And finally, a denoised focus, cutting through the hype to zero in on high-impact areas that really matter.
It really all boils down to the simple, elegant principle. True intelligence, whether it's in a human or in a machine, isn't just about raw power. It's a ratio. It's about how much useful, adaptive behavior you get for a given amount of complexity. Nature figured this out over millions of years of evolution, and now AI engineers are learning the exact same lesson.
This quote just nails it. AI has become the undisputed champion of the digital realms, the pixelverse of images and the codeverse of software. But the ultimate test, the final frontier, that's the reality-verse. That's our world. And that, right there, is the big question we're all left with. AI's intelligence is powerful, it's efficient, and it is profoundly alien to our own. It has completely conquered its native world of pure data. The real question is, when, and more importantly, how, will it finally master ours?